Okay, here's question number 6, and this is what it says. A series of tests were carried out on 6 unknown substances. The results of the tests are shown below. So I've got a whole bunch of properties that we've tested these substances for. Using the information above, identify each material as having ionic, metallic and covalent molecular or covalent lattice structure. So we've got the properties and we need to understand what the properties of these things are. So what are the properties? Melting point, malleability, solubility, electrical conductivity and electrical conductivity as a liquid. So from that, I can then think about what are my properties of ionic compounds, metallic compounds, and so on and so forth. I should know that metallic compounds, these guys, they conduct electricity really well as solids. So if I look at my solid here, the only one that conducts electricity well is E. So I'm going to say, therefore, that is metallic, okay, because I know that that's going to be what we can actually do. Metals are also malleable, which means that is a malleable substance. That makes sense as well. And this metal in particular has a high melting point. That kind of makes sense. Metals have a range of melting points. So that's going to be our metal. What else do I know? I have ionic compounds. These guys are brittle and have a high melting point. All right. And they conduct electricity when they're dissolved or as liquids. So let's have a look at conducting electricity as a liquid. So electrical conductivity as a liquid, I can see that this guy doesn't conduct electricity as a solid. That's an ionic as well. So this guy's going to be ionic. And again here, this guy's going to be ionic as well because he conducts electricity as a, what's it called? As a liquid. Alrighty, cool. So that's going to be ionic as well. These guys do not conduct electricity in either form, so therefore they're not going to be ionic or metallic. They must be covalent. So how do I know if it's going to be covalent molecular or covalent lattice? Lattices have a high melting point. So therefore, I'll look for my covalent. This has got a massively high melting point, so it's going to be covalent lattice. Covalent lattice because of the high melting point, no conductivity of electricity, no malleability, it's not going to dissolve. Next, I've got covalent molecular. These guys have very low melting points, so therefore it's going to be covalent molecular, and this is going to be covalent molecular. And therefore, we have got that. Now, part B. Discuss the reasons for the possible difference in solubility between substances A and C. Well, let's have a look at A and C. A and C, what we've got? This is highly soluble, this is a low solubility. They're both ionic. So both are ionic. One dissolves a lot, one dissolves a tiny bit. The reason why things dissolve is because they're charged. So A probably has a charge of +1 and -1, and C might have a charge of +2, -2. And so therefore the difference in solubility is to do with the difference in force. So therefore A has a lower ionic electrostatic force holding it together than C. Or you could say the opposite as well, that C must have a higher electrostatic force holding our molecule together. That's the idea between the difference in solubility of ionic compounds. It's to do with the force holding those ions together. And you need to try and word that nicely here. I haven't worded it very well, but I've done a diagram in terms of explaining the fact that the difference in force here, A is probably between a lower charged ions, and C is between higher charged ions, which makes it harder for it to dissolve. Question C, explain the reason for the low boiling point found in substance F. All right, so what's substance F? It's over here. It's a covalent molecular compound, and it has a super duper low boiling point. Okay, so therefore covalent molecular, low boiling point. The reason why you would have a low boiling point in a covalent molecular force is to do with the intermolecular forces. Intermolecular force, molecular forces happening, and therefore it's probably most likely that compound F is non-polar and a very small compound, all right, or very small molecule, because the forces have to do with two things. One, the type of force, where you have hydrogen bonding, dipole, bonding, or dispersion forces. Okay, so it's got dispersion forces because that's the weakest of those three intermolecular forces, and the dispersion force depends on the size / molar mass of the compound. So therefore, because it's so low, we would assume that it's going to be a non-polar, very small compound as substance F. And that now is the end of this test. This question was all about identifying properties and what you can tell about the bonding within a molecule or a compound based on the properties that you have. And you need to be able to know how these materials properties kind of are exhibited and where they come from. Melting point is all about the force holding the things together. Malleability is about the structure. That's mainly to do with ionic and covalent, ionic and metallic compounds. Solubility is about force again. Electrical conductivity is about charged particles being able to move. So if I was to look at this and say these two things here, that's about forces, okay? And these two things here are about charged particles. And that's when I go through, and each time I'm really thinking about what force is involved in these types of compounds. Probably over-explained that and not done a great job of that, but you've got another practice test that you can look at anyway, so my suggestion is to have a look at that at some stage. That's practice test 1A done.